Okay, so for this problem, we need to do all of the steps and solve the following system equations using matrices. So I first take my system and I'm going to rewrite it in a matrix with just the coefficients. Now, this can get a little overwhelming, so just do as many steps as you can. I know a lot of students get overwhelmed because it's such a hard problem or such a long, so many steps that they just skip it. Don't do that. I think everyone can at least write this equation down from the equation to the matrix. Okay. So the first goal that I want a 1 to be up in the upper left-hand corner. To get a 1 there, one easy way to do that is just to take row 3 that already has a 1 in it and interchange it with row 1. So who stays the same? Well, in this case, row 2 stays the same, and then I can switch row 3 with row 1. Okay, so guess what? It's time for a progress report. I've got a 1 exactly where I want it. Now I want to get a 0 below it and a 0 below that. This is the only step where you can do 2 row operations on the same step to progress you forward. So in order to get a 0, okay, so in order to get a 0 for the negative 2, I'm going to take the opposite sign of negative 2, which is positive 2, multiply it by the row with a 1 in it, which happens to be row 1, and add it back to the row. At the same time, I'm going to do row 3 needs to have a 0 there. In order to get a 0, I'm going to take the opposite of positive 2, which is negative 2, times it by the row with a 1 in it, and add it back to the row, put it back in that row. So on the next matrix, who stays the same? Well, only row 1 is staying the same. And in fact, once you get row 1 to have a 1 in it, it's going to stay the same the whole time. So for the green operations, I can either do this horizontally or vertically. I don't really care which way you choose to do it. Just pick a way that you like. I'm going to do one way and one the other just so you can remember and see them and decide which one you like. So I don't know, I would guess this called this vertically, I guess. So I'm going to take 2 times row 1. So I take row 1 and multiply it by 2. So 1 times 2 is 2. Negative 4 times 2 is negative 8. 2 times 2 is 4. 11 times 2 is 22. And then I put row 2 underneath it. And then I add down. So row 2 becomes 0, negative 7, 7, and 42. Now if you didn't like that way, you could do it horizontally, and I'll show you that now too. So we have negative 2, and I'm going to write that 4 times, times row 1 plus row 3. So the row 1 happens to be 1, negative 4, 2, and 11. And then row 3, because I'm doing row 3 this time, 2, 2, negative 1, negative 13. And then when I work it out horizontally, I get 0. And the next one I get positive 8 plus 2 is 10. Negative 2 times 2 is negative 4, minus 1 is negative 5. 2 times negative 2 times 11 is negative 22. Minus 13 is negative 35. Okay, time for a progress report. Do I have a 1? Check. I didn't manipulate that at all. I have a 0 below it. Yes, yes. Next, I'm looking for a 1 where the negative 7 is in row 2, column 2. In order to get a 1, I need to multiply by the reciprocal. I can't interchange 2 rows because that really only works for the first step. So now I need to multiply by the reciprocal. The reciprocal of negative 7 is 1 over negative 7. Notice that I didn't change the sign. I just put 1 over whatever the number was, in this case negative 7. So I'm going to multiply 1 over negative 7 by row 2 and put it back into row 2. So which rows stay the same? Well, row 1 and row 3 are going to stay the same. Now row 2 is going to be multiplied by 1 over negative 7. Now sometimes students don't really like multiplying by fractions. If you were one of those students, you can think of it as divide by negative 7. Even though we have to write it as 1 over negative 7, you can think of it as a divide by, because that's what it means when it's in the denominator. So 0 divided by negative 7 is 0. Negative 7 divided by negative 7 is positive 1. Positive 7 divided by negative 7 is negative 1. And 42 divided by negative 7 is negative 6. So now it's time for another progress report. Do I have a 1? Yes. Do I have zeros below it? Yes, yes. Do I have a 1? Yes. So the next thing I'm looking for is a 0 below it. Notice if you're doing it in the right order, you're not manipulating any of the ones and zeros that you've already successfully got. Okay? So now I need a 0 below the 1 where the 10 is. In order to get a 0, I'm going to take the opposite sign. The opposite sign of 10 is negative 10. Multiply it by the row with a 1 in it. Well, in this column, column 2, the row with the 1 in it happens to be row 2. And I'm talking about the one that we just worked on, okay? Add it back to the row. And I've given you an example of doing the addition horizontally and vertically, so at this point you need to choose which one you like better. I guess I'll go ahead and do it vertically here. So negative 10 times row 2, so negative 10 times 0 is 0, negative 10 times 1 is negative 10, negative 10 times negative 1 is positive 10, and negative 10 times negative 6 is positive 60. And then you put row 3 right under it, and then you can add down. So in my next matrix, I should have written row 1 and row 2 weren't changing at all. When you're bringing down the rows, just be real careful that you're not dropping a negative or interchanging two places. That's where a lot of student mistakes come from. They do all the problems right, but then they accidentally transpose a negative. So just be real careful there. Okay, progress report time. Do I have a 1? Check. Do I have zeros below it? Check, check. Do I have a 1? Yes. Do I have 0 below it? Yes. So that means the next thing I'm working on is that 5 needs to become a 1. So in order to get it to be a 1, I'm going to multiply it by its reciprocal, 1/5. So what rows stay the same? Well, row 1 and row 2 are staying the same. And if you don't want to think of it as multiply by a 5th, you can think of it as divide by 5. 0 divided by 5 is 0. 0 divided by 5 is 0. 5 divided by 5 is 1. 25 divided by 5 is 5. Okay, progress report. I have a 1, yes. I have zeros below it, yes, yes. Do I have a 1? Yes. Do I have zeros below it? Yes. Do I have a 1? Yeah, I'm pretty satisfied. I have this in row echelon form. So now what I can do is write it in the equation form. Okay, and now I'm going to take one extra step and solve it for the x, the y, and the z so that it's a little bit easier. So I have x equals, I'm going to move the negative 4 and the 2z to the other side. So when I move negative 4y to the other side, that becomes positive 4y. When I move positive 2z to the other side, it becomes negative 2z. And 11 stays the same. Okay, for the y equation, I move the z over, that becomes positive z minus 6, then minus 6 stays the same. And then z equals 5, that's actually already solved. So my ordered triple, I have z in the 5 in the z spot. For the y, I can take z and replace it with 5. So 5 minus 6 is negative 1. So y is equal to negative 1. And then for The x, I can replace both y and z. So the y is -1 and the z is 5, which gets me -4 minus 10, which is -14, plus 11, which is -3. So this is what I believe my ordered triple is. If you want, you can go one step further and check your work. So I went ahead and rewrote it down here just so it would be a little bit easier for us. So if you want to check your work, and you don't necessarily have to, you can take your x, your y, and your z and plug it in and make sure that it equals what it's supposed to equal. So I have 2 times -3, because that's my x, is -6. 2 times -1 is -2. And -6 minus 2 is -8 minus 5 is -13. And yes, that works. Let's try the next one. So we have -2 times -3 plus 1 times -1, which is y, plus 3 times z, which is 5. Let's see what that adds up to be. 6 plus a -1 plus 15. So that's 5 plus 15 is truly 20. Yay, that one works too. And then I have x, which is -3, minus 4 times y, which is -1, plus 2 times z, which is 5, and let's see what that adds up to be. -3 plus 4, which is +1, and 1 plus 10 is 11. So guess what? This is the only unique answer that works for all three equations, and I have found my solution.